Sir, now the next case related to overloading. Observe a bit carefully, sir. Here class test public void M1 of int I comma float f. Sir, how many arguments are there? Two arguments. What is the first argument? Int. Second argument float. Public void M1 float f comma int I. Sir, float argument, int argument. Now I have one small doubt. Can you please tell these two methods are overloaded or not? Yes, friends, overloaded or not? Yes, because both the methods should have same name, but different argument types. At least order. Here, first method signature int comma float. M1 of int comma float. Second method signature M1 of float comma int. Observe the difference, right? M1 of float comma int. That's why at least there is a change in argument order. That's why both are overloaded methods. Okay, well. Now, test T is equal to new test. Now I'm trying to take T dot M1 of 10 comma 10.5 F. Can you please tell which method will get the chance? Respond, man. Which method will get the chance? Int and float. So in overloading, exact match is always going to get highest priority. That's why int float. So which one will get the chances, sir? Int float version will get the chance. Regarding int float version will get the chance. Similarly, T dot M1 10.5 F comma 10. 0.5 F comma 10. Do you know float value, int value? Float value, int value. So highest priority, exact match. Float, int. That's why which method will get the chance? Float int version will get the chance. Okay, well, because you are passing one float value, one int value, float int. Here you are passing one int value, one float, int float, like this, right? Let me execute up to this one. Have a look once. Here I am taking. So same thing only. First method, int float version. Second method, float int version. We have test T is equal to new test. T dot M1 10 comma 10.5 F. Okay, well, 10 comma 10.5 F. Have you observed? The code compiles fine. The code compiles fine. Int float version we are getting because you are passing int value, float value like. Sir, similarly, T dot M1 10.5 F comma 10. You are getting 10.5 F comma 10 like this, right? Now, which one is going to get in the chance, right? Float int version will get the chance. Are getting which one will get the chance? Float int version will get the chance, right? Okay, well, this is the float int version, right? Sir, up to this okay, because exact match always going to get high priority, right? But now the next thing what I have to discuss is, sir, take very special care. Now the cinema is going to start. Observe carefully. T dot M1 10 comma 10. Can you please confirm? Which one is going to get in the chance? First one, int value. Second one is also int. Array, both are int. You are passing int. Which one will get the chance? First one, matched. Int. Second one is expecting float. Int can be promoted to the float. No problem. So, int float version. Maybe first one matched. Second one, float. Int value will promote to the float. Second one, int, no problem. Second one also matched. If I can ask this question in my offline classes, out of 100, 99% of the people are always going to tell, sir, first one will get the chance, sir. Sir, first one will get the chance because 10, int 10, exact match. Second one will be promoted like this. That's why first one is always going to get in the chance because left to right. Left to right. You are giving the chance for precedence for left to right. That's why first one is getting the chance right. Then immediately I will ask. Okay. In India, we are always giving the precedence from left to right. But if you go for Pakistan, in Pakistan, they are always going to give the precedence from right to left. Then in Pakistan, 10 int matched. Second argument from right to left means int will be promoted to the float. Array means in India, first version will get the chance, but in Pakistan, second version will get the chance. Java language is the country dependent language, platform independent anyway. Is the country dependent language? No right. Okay. Can you please tell who is going to get in the chance? Compiler will give left and right. Array, both methods got matched, man. Which method? I'm not in a position to resolve. Reference to M1 is ambiguous. Are you getting? Reference to M1 is ambiguous. This is the comparative method by default we are going to get. Okay, please make sure you should aware. Now observe that. Observe a bit carefully, sir. Here I'm taking T dot M1 of 10 comma 10. T dot M1 of 10 comma 10. If I can take like this, observe, immediately comparative method we are going to get int float. Sir, here reference to M1 is ambiguous because both methods got matched, man. So this is, are you getting? Very important case. There is no precedence like left to right, right to left while resolving method arguments. That's why. So immediately error we are going to get. Now I have one more case, right? Okay, well, let me comment this one. Now T dot M1 10.5F. Sir, both are float. Both are float. Can you please tell who is going to get in the chance now? First one, not matched. Because first argument is always expecting int, but you are providing float. So float to int conversion not there, int to float is there. So it is a wrong. Second one, not matched. Because in the second method, second argument is what type? Int type. But here you are passing float. In the place of int, you can't pass float value. First method not matched, second method not matched. So no method matched. That's why cannot find the symbol method M1 of float like we are going to get the problem. Okay? Like, sir, do you know? In the previous case, 10, both methods matched. That's why compiler getting confusion, ambiguity problem, right? But in the second case, no method matched. That's why cannot find the symbol. There is no such type of method. Okay, like, let me execute this code. Now, here I'm taking, this one I'm trying to comment. T dot M1 of 10.5F, comma 10.5F I'm taking. 10.5F, comma 10.5F. Can you please observe? That? Immediately, have you observed? No suitable method found for M1 of float. Sir, int float is not applicable. Float int is also not applicable. That's why no suitable method found like this. Immediately it's going to tell compile time error. Everyone can able to understand? So because no method matched, that's why it is invalid. Here both methods got matched. That's why it is invalid. Sir, very important case for the entire room. Take special care. Sir, the last case related to overloading, a bit important, take special care, sir. Here I am taking class animal. Are you getting? I am taking class animal. Next, I want to take child class of animal. Can you please tell any child class? Refer animal, child of animal. Maybe tiger, lion, next to human. Human being is also child of animal only, right? Human, like. Sir, my favorite animal, class monkey. Class monkey extends animal. Class monkey extends animal. Animal like. Sir, why monkey is my favorite animal? Because most of software engineers like us are monkeys only. Monkeys. Most of software engineers are monkeys. Because the reason is, so for the sake of some 20% hike, 30% hike, so we are going to keep on changing the company. Today I'm in Infosys. Tomorrow I may jump to IBM because IBM people are offering 30% hike. Day after tomorrow I may jump to TCS because they are offering more, another 20% hike. That's why, so software engineer like me keep on jumping from one tree to another tree. Same one software company to another software company. Like anyway, monkey is the best example. Class monkey extends animal. So which is the parent class? Animal is the parent, monkey is the child class, right? Now class test. Observe very carefully, dangerous case. Public void M1 of animal A. Public void M1 of animal A. System.out.println animal version. Observe carefully, sir. Animal version. Sir, what is the argument for M1? Animal version. Public void M1, another method, monkey version. Are you getting monkey? M system.out.println monkey version we have. Monkey version like this, right? Of course, sir, animal and monkey, my own classes. Can I use the word these two methods are overloaded or not? Yes, because both methods having the same name but different argument types. Okay, well, now I'm ready to go for main method, sir. Public static void main method string array args. Okay, string array args. Now the point is, test T is equal to new tester, because if you want to call either this M1 method or this M1 method, both are instance method, test class object must be required. Now observe first one. Animal A is equal to new animal. Animal A is equal to new animal. Sir, I'm creating animal object. Reference type animal, runtime object is also animal object only. T dot M1, I'm passing A. This is the first one. Second, can you please observe? Monkey M is equal to new monkey. Monkey M is equal to new monkey. T dot M1 of M. T dot M1 of M like this. Next, the third one. Animal A1 is equal to new monkey. Animal A1 is equal to new monkey. T dot M1 of A1. Wow, wonderful case, sir. More concentration must be required. Sir, parent reference can be used to hold child object, no problem at all. Here child reference, child object. Okay, well, can you please confirm which one will get the chance in the first case? Observe carefully. Animal reference, animal object, T dot M1 of A. Exact match will get highest priority. Sir, A, animal version. Don't keep any doubt at all. Animal version. I will execute. Don't worry, sir. Next, monkey M is equal to new monkey. T dot M1 of M is, sir, monkey exact match is there. That's why, sir, monkey version. Monkey version like this, right? Dangerous thing, third one only. Animal A1 is equal to new monkey. Parent reference can be used to hold child object. T dot M1 of A1. Can you please tell animal version or monkey version? Very, very important. Animal version or monkey version, because both methods are there. There is one method which can take animal type. There is one method which can take monkey type. Who is going to get in the chance? That's what. At the beginning of overloading, I covered one point. How many people remembered? I don't know. I covered one important point, sir. In overloading, method resolution always takes care by compiler based on reference type. Runtime object never going to play any role. Remember, here which reference A1 is what type? Animal. So this is it, never going to worry about runtime object. So that's why which version will get the chances, sir? Animal version only. Remember this, sir. Which version will get? Animal version, sir. Practical proof. In overloading, always method resolution is always based on reference type, but not based on runtime object. Any doubt, friends? Are you in the position to understand? Let me execute this code. Observe that carefully. Here I am taking, sir, same. Observe code, class animal, sir. Next class monkey extends animal. Next, there is one method. First method, animal version. Second method, monkey version is there. Now I am taking animal A is equal to new monkey. Animal A is equal, Animal A is equal to new animal. Like this I am taking, sir. Now T dot M1 of A, sir. T dot M1 of A. Sir, animal reference, animal object. Then obviously animal version is the output we are going to get. The code compiles fine. What is the answer, sir? Animal version. Okay, well. Now, sir, here next case I am taking monkey M is equal to new monkey. Monkey M is equal to new monkey. T dot M1 of M, sir. T dot M1 of M like this I am taking, sir. Now, can you please confirm what is the answer by default you are going to get, sir? Have you observed? Monkey version. Clear for you people, right? Sir, third case, very important, sir. Animal A1 is equal to new monkey. Animal A1 is equal to new monkey. T dot M1 of A1. T dot M1 of A1. Can you please confirm what is the output by default you are going to get, sir? Yes, clear for you people? Yes, animal version. Like this we are going to get. Okay, please make sure in overloading, method resolution always takes care by compiler based on reference type. A runtime object is a dummy in overloading. So hence overloading is also considered as compile time polymorphism or static polymorphism or early binding. Clear for you? Is it clear for all of you, right? In the last two videos, we covered overloading concept very clearly, right? Sir, now the next concept what I have to discuss, overriding. Regarding what is the next topic, sir? Overriding, the most valuable concept. You people should require to take special care. Here just observe, I have class P. Now listen very carefully, sir. Sir, whatever methods parent has by default available to the child class or not? Can you please tell? Yes. Through which property? Inheritance property. Whatever methods parent has by default available to child class, the child class directly can use without rewriting. Okay, like sometimes child class may not satisfied with the parent method implementation. If the child class not satisfied with parent method implementation, then the child is allowed to redefine that method based on its requirement. Regarding such type of concept is called overriding. Sir, let me go for a small example, then you people can feel more comfortable, right? Observe that class P, sir. Do you know, every parent want to provide huge property to the kid. So if you can ask your father, at this age also why you are working this much hard? then your father is always going to tell, Arey, for the sake of you only. Okay, you have to be enjoyed. That's why I'm working like anything, like every parent in the world is always going to, sir, do the work to provide huge property to the kid. Assume that. So now, class P, public void property. Public void property. Like there is one method is there, sir. So the property in which form they are going to provide? System.out.println maybe in the form of cash, or maybe in the form of gold, or maybe in the form of land. Assume that maybe in this form. Okay, parent contain property method. Parent, every parent in the world is very much eager to provide marriage for the kid. Assume. So now parent want to arrange marriage for the kid. Assume that public void marry, system.out.println. Okay, parent arranged marriage with some appalamma. Okay. Assume that or Subbalakshmi, like sir, parent arranged marriage with Appalamma or Subbalakshmi, something like I took, sir. Now Telugu names, these names are my local language Telugu names. Okay, some what we call a bit the people who are coming from very rural village, such type of names are these. Okay, assume. So now class C extends P, sir. Do you know whatever methods parent has by default available to the child? Property is coming, and after that marriage is also coming, sir. So now this child very much satisfied with property implementation. Sir, I want property as it is. I want property as it is. But I'm not satisfied with this marriage implementation. I don't want Appalamma or I don't want Subbalakshmi. Sorry, I'm not satisfied with that. If the child class not satisfied with parent method implementation, then the child is allowed to redefine that method based on its requirement. Are you getting? Now, sir, this process is called what? Overriding. Now, this child class want to provide implementation for which methods are marry method. Are you getting? Public void marry method. System.out.println. Observe that he is not satisfied with this. That's why he is defining his own. Child may have some option in their mind. Okay, something like Katrina Kaif or Sunny Leone or something like okay, he can able to take this one. Are you getting? So whatever methods parent has by default available to the child through inheritance, if the child class not satisfied with the parent method implementation, that particular method child class is allowed to redefine. This concept is nothing but overriding. Everyone can able to understand, right? Sir, this concept itself is nothing but overriding concept. Okay, well, sir, it is overriding like this, right? Next, the parent class method, which is overridden. Sir, this method is overridden. Regarding the parent class method, which is overridden, this method is called overridden method. Regarding this method is called overridden method. Parent class method, which is overridden, is called overridden method. Child class method, which is overriding, is called overriding method. Observe a bit very carefully about this terminology, right? Okay, please make sure, observe carefully, right? Okay, sir, now the point here, take a bit very special care about this one. So whatever method parent has by default available to child through inheritance, if the child class not satisfied with parent method implementation, then the child is allowed to redefine, which is nothing but overriding. The parent class method, which is overridden, is called overridden method. The child class method, which is overriding, is called overriding method. That's all. This is what is overriding. Are you able to understand? So, if the child not satisfied with the parent method implementation, then the child is allowed to redefine, which is nothing but what? Overriding concept. Okay, now, sir, observe carefully how the method resolution will be there. Very, very important. Sir, I'm taking class test. I'm taking class test like this, right? Sir, now public static void main method string array args. Public static void main method string array args. Okay. Now here legend this one. Sir, I hope everyone can able to understand what the meaning of overriding, right? Sir, now my target is, sir, parent P is equal to new parent. Can you please tell reference is what type? Parent type. And the new parent P dot marry method I'm taking. What I'm taking, sir? Can you please spell out? P dot marry method I'm taking. Sir, which reference I'm using? Parent reference, parent object, P dot marry. Sir, there is no ambiguity. Always parent method will get the chance. Sir, which method will get the chance? Parent method will get the chance, sir. Parent method, because you never talk about child reference or child object, everything is a parent method will get the chance. So C is equal to new C. I'm creating child class object. C dot marry method I'm taking, sir. C dot marry method. Sir, child reference, child object, child already contain marry method. That's why child method will get the chance. Child method will get the chance. Sir, there is no speciality up to this. Now, the next point you people should aware. Parent reference can be used to hold child class object. Parent reference can be used to hold child class object. Sir, P1 dot marry method I'm calling, sir. Can you please confirm which marry method will come? Because have you observed? Marry method is available in the child class. Marry method is available in the parent class. Overriding happens, sir. Can you please tell if parent P1 is equal to new child, P1 dot marry, which method will get the chance? Sir, we are using which word? Overriding concept. Which method will get the chance? Now take very special care in this. What is the role of compiler? What is the role of JVM? Sir, you are calling marry method on P1. Observe very carefully. We are calling marry method on P1. P1 is what type? P type. P1 is what type? P type. P type. Now, in the parent class, marry method is available or not. Compiler is always going to check. Can you please observe? In the parent class, marry method is available or not? Yes, available, no problem at all. So, up to this compiler's role. Let me repeat again. Sir, I am calling marry method on the P1. P1 is what type? Parent type. Now, in the parent class, marry method is available or not. If it is available, compiler give the green signal. If it is not available, immediately comparative method we are going to get. Sorry, you can't call a marry method on P type of reference. It's right, but it is available, no problem. At runtime, JVM is always going to check which is the runtime object. Runtime object is what? Child class object. Regarding runtime is child class object. At the runtime, JVM will check in this child class is the marry method is overriding or not. In the child class, if the marry method is overriding at runtime, JVM is always going to give the chance for child class overriding method only. That's why which method will get the chances are child method will get the chance. Observe very carefully, sir. Child method will get the chance. So means that in overriding method resolution always takes care by JVM. Who is the responsible, sir? Method resolution is always takes care by JVM based on runtime object. So here which runtime object I am using? Child. That's why child method. Here which runtime object I am using? Child. That's why child method. Which runtime object I am using? Parent. That's why parent method we are going to get in the chance. So please make sure you people should aware, should inject this point very strongly in your mind. In overriding, method resolution always takes care by JVM based on runtime object, not based on reference type. Remember, that's why overriding also known as runtime polymorphism. Regarding overriding is also known as runtime polymorphism, or dynamic polymorphism, runtime polymorphism or dynamic polymorphism or late binding. Are you getting? Or late binding. That's all. Please make sure you people should be aware. So overriding is also considered as runtime polymorphism or dynamic polymorphism or late binding. Clear for all of you, right? Sir, let me execute this code, sir. Observe carefully. Have a look once. Observe a bit carefully, sir. Class P, parent class contain, sir, public void property method is there, sir. Gold, land, cash, something like. Public void marry, sir, here marry with the marriage with so what we call Appalamma, Subbalakshmi, something like I'm taking, right? Sir, class C extends P. Sir, now child class not satisfied with marry implementation. That's why child is trying to override this method. So this concept itself is nothing but overriding. Please make sure you people should aware very clearly, right? Okay, overriding. Now inside test class, sir, P is equal to new P, sir. P is equal to new P dot marry. Sir, here runtime object is always parent object. Obviously, parent method will get the chance. Parent method, marry method means Appalakshmi, so Appalamma, Subbalakshmi, something like this. It is there, sir. Okay, here parent method, like some small change. This method is child method. Like this I'm taking, sir. Now observe this. So which method will get the chance? Parent method will get the chance. Now have a look once. The code compiles fine. Sir, what is the output? What is the output by default we are going to get? Parent method, we are getting the chance. Are you getting that? Which method? Parent method will get the chance. Sir, now child C is equal to new child I'm taking. Child C is equal to new child C dot marry I'm taking, sir. Are you getting? Now child reference, child object. So runtime object is always what type? Runtime object is always what type? Child object. That's why obviously child class method will get the chance. Remember, now let me execute second output. Can you please observe that? Child method we are getting. Are you getting? Child method Katirna. Like that we are getting, sir. Sir, last one, very dangerous point. Parent P1 is equal to new child. Are you getting? Parent P1 is equal to new child P1 dot marry. Are you getting? Parent P1 is equal to new child P1 dot marry. Sir, this line is the very important. Take special care, sir. Sir, we are calling marry method on P1. P1 is what type? Parent type. Compiler is always going to check in the parent class marry method is there or not. In the parent class, if marry method is not there, compile method, right? But anyway, parent class contain marry method, happily code compiles fine. Yet runtime, JVM is always going to check in the child class, is this method is overridden or not. In the child class, if this method is overridden, at runtime, based on runtime object, child class method is always going to get in the chance. Remember, in this case, which method will get the chance? Parent class contain marry, but child class also contain marry. Based on runtime object, child class method is always going to get in the chance, right? Now observe that. Let me execute this code, sir. What is the output? By default, we are going to get. Happily the code compiles fine. What the last answers are? Child method like this, right? Any doubt? Are you in the position to understand, right? In overriding, method resolution is always based on runtime object. Sir, who is the responsible to take care? JVM. Overriding method resolution is always takes care by JVM based on runtime object. Hence, overriding is also known as runtime polymorphism or dynamic polymorphism or late binding. Clear for all of you, right? Any doubt, friends? Sir, in the last videos we covered what is overloading, what are various important rules, what is overriding, basic idea about overriding, next method resolution in overriding, everything we covered, right? Overriding is not the easy process. Remember this one, there are several rules associated with overriding. But if it's the overloading, very simple process, right? In overloading, we have to check only method names, argument types. Method names must be same, argument types must be different. Remember, that is the rule of overloading. But in overriding, we require to check several things like modifiers, return type, throws keyword, like there are several conditions we have to check in overriding. That's why overriding is not that much easy process. We have to take each and every loophole internally. Clear, right? So now, what rules are there for method of overriding? Okay, first rule, sir. Okay, here I'm taking here just class P. Observe very carefully, sir. Class P. I have public void m1 of int I is there, sir. This is the method what we have, class P, public void m1 of int I. Sir, now I'm taking class C extends P. Are you getting? Class C extends P, public void m1 of int I, like this I'm taking. Can you please tell, is it valid overriding or not? Yes, friends, is it valid overriding or not? Yes. Here, first rule what we have to check, what we require to take care. So in overriding, method names must be same. Method names must be same, and argument types must be same. Are you getting? Including order also. Method name must be same, argument types must be same. Are you getting? So that is method name followed by argument type is nothing but what? Method signature. Correct or not? Method signature. So in overriding, method signatures must be same. Method signatures must be matched. So method names and argument types are same means method signatures must be matched. This is the rule number 1. Remember, right? Sir, what is the second rule? The second rule is what about return type? Are you getting? What about return type? Return type. Can you please confirm? Return types must be same or may be different? Yes, friends. Return types must be compulsory same in overriding or can be different? Can you please confirm? Yes, friends. So return types must be same in overriding, but this rule is applicable until 1.4 version. Are you getting? But this rule is applicable until 1.4 version. From 1.5 version onwards, covariant return types also allowed. Are you getting? From 1.5 version onwards, covariant return types also allowed. Then immediately you may ask, sir, what is the meaning of covariant return type? Very simple, sir. Just let me go for a small example, then you people can able to understand very easily, right? Here I have class P, parent class is there. Assume parent class method return type is object, sir. Assume that the return type of parent class is object, public object m1. So it is expecting some return value, return null, acceptable, syntactically valid, because it has to return some object, return null, acceptable, right? Now I want to override this method in the child class. Class C extends P I'm taking. Now I want to override, sir. Here public object m1. Sir, return null, like this I'm taking, sir. Sir, here have you observed the return type, here object and here object, no problem at all. If the same return types are there, no issue at all, right? But from 1.5 version onwards, we have more flexibility. Covariant return types also allowed. What is the meaning of covariant return type? Means the child method return type need not be same as parent method return type. It's a child types also allowed. Can you please tell for object what is the child? String or string buffer or anything. So it's a child types also allowed. So means that need not be object. Happily you can take string also. Happily you can take string buffer also. Integer also, like any child class of this object is allowed, no problem at all. Such type of return types are called covariant return types, right? But please make sure this concept is applicable only from which version? 1.5 version onwards. Okay, so child class method return type need not be same as parent method return type. It's a child types also allowed. This is nothing but what? Covariant return type concept. Now I have one small doubt, sir. Can you please tell, if I compile this code, if I compile this code, is it valid or invalid? Is it valid or invalid? In 1.4 version, invalid. Because in the 1.4 version, return types must be same. But in 1.5 version, from 1.5 version onwards, perfectly it is allowed. Because from 1.5 version onwards, covariant return types also allowed. Everyone can able to understand, right? Observe very carefully about this type of terminology, right? Okay, let me go for this one, sir. Observe carefully. Let me execute this code. Have a look once, sir. Here I'm taking just the same example, whatever there, sir. Here class P, just observe that class P, public object M1 method, public object M1 I'm taking, just return null I'm taking, sir. Public object M1 return null, like this I'm taking, sir. Here same class C extends P. Are you getting? Class C extends P, public object M1. Sir, whether you are using 1.4 version, 1.5 version, in all versions, this one is perfectly valid because I'm maintaining same return type. That's why perfectly valid, sir. Now let me compile this code. Here just observe. Let me go to my working directory, right? Yes, here just observe that Java C p.java, perfectly valid. We never going to face any problem, sir. Now instead of object, here I'm taking string, sir. Here I'm taking string. Can you please confirm in 1.8 version, because I'm using which version of compiler, sir? Java C version. Observe that which version of compiler I'm using? 1.8 version, sir. Okay, in 1.8 version, is it allowed or not? Yes, perfectly allowed, no problem at all. Now let me compile this code. Yes, it is valid, sir. Now I'm asking Java C source 1.4 p.java. Boss, can you please compile this code? According to 1.4 version, we can compile a Java program according to a particular version by using source option. Remember this one. So can you please compile this p.java according to 1.4 version? Now I'm asking, in 1.4 version, can you please tell, is it valid or invalid? Is it valid or invalid? Invalid, because in 1.4 version, return types must be same. So covariant return types concept applicable from which version? 1.5 version. That's why this one is invalid. Compiler is ready to give left and right. Observe that carefully, sir. Here have a look once. Sir, here one error. So M1 in C cannot override M1 in P. Return type string is not compatible with the object. Like this it's asking, sir. But the same question I'm asking in the 1.5 version. I'm asking in 1.5. Can you please compile according to 1.5 version? Yes, perfectly valid. Here, just we are getting warnings, man, but not error. But earlier we got error. Observe the difference, right? Itself is valid. So, this is the small rule what you people should be aware about sir, overriding a return types concept. So, is it clear for all of you, right? Until 1.4 version, return types must be same in overriding. From 1.5 version onwards, covariant return types are allowed. Okay, sir, which is called covariant return type? Child method return type need not be same as parent method return type. It's a child types also allowed. This concept is called covariant return types concept. Clear for you, right? Sir, now if you feel comfortable, just I will keep more elaboration on this covariant return types concept. Okay, sir, now just observe parent method return type, child method return type. Sir, if the parent method return type is object, sir, can you please tell which types are allowed for child method return type? Yes, either object is allowed, or its child classes are allowed. Like string concept is allowed, string buffer concept is allowed, string buffer is allowed, dot. Remember that. So if the parent method return type is object, now the child method return type is either object is allowed or its child types are allowed. Okay. Similarly, if the parent method return type is a number, then for the child, which types are allowed, sir? For the child, which types are allowed? Number is allowed, integer is allowed, number is allowed, integer is allowed, float is allowed, dot. Number are its child classes. Do you know? For number, what are various child classes are there? Wrapper classes, right? Byte, next and after that short, integer, long, float, double. Are you getting? Float, double. Like these things are various child classes of number. That's why either number is allowed or its child classes are allowed. Okay, these are wrapper classes, right? Okay, like next, similarly, here observe, I'm taking in the parent method return type is a string, sir, string. But child method return type I'm taking as object. Are you getting? Can you please confirm, is it valid or not? Respond, is it valid or not? So, what is our rule? Child method return type need not be same as parent method return type. It's a child types also allowed. But here you are taking child method return type is the parent of parent method return type. For this string, I'm taking object as the parent. Sorry, this one is not acceptable. Okay, so it should be either same or it's a child, but not its parent. Here I'm taking its parent. Immediately compiler will give left and right. Remember this one. Just I have a look once, sir. Here I'm reversing the content. Here just I'm taking, here string I'm taking, sir. But here object I'm taking. So in the parent string, but in the child I'm taking object. So child method return type I'm taking parent of parent method return type, which is not covariant return type. That's why immediately compile method we are going to get. Observe that, sir. Here I'm trying to compile according to our original version, 1.8 version only. Immediately compile method we are going to get. Have you observed, right? M1 in C cannot override M1 in P. Return type object is not compatible with the string. Return type object is not compatible with the string. Like this compile method we are going to get. Clear, right? So next, so this one is not a covariant return type, right? Now I'm taking, here observe carefully, sir. Double. I'm taking int, sir. Double int. Can you please confirm, is it valid or not? Double int, is it valid or not? Okay, please make sure. If you are trying to take like this, compiler will give left and right because covariant return type concept applicable only for object types but not for primitives. Regarding it's applicable only for object types but not for primitives. That's why this one is invalid. Comparative method we are going to get. In the case of primitive, whatever return type of the parent, compulsory child method return type must be same if a primitive return type. But in the case of object types, covariant return types are allowed. Is it clear, right? Sir, let me cross check here. Observe that carefully, sir. Here I am taking double, sir. Double. If I'm taking double, so okay, sir, return some double value. Here I am taking int, sir, return some int value like this, right? Now have a look once. Immediately we are going to get m1 int c cannot override m1. Return type int is not compatible with the double. So covariant return type concept not applicable for primitives. It is applicable only for object types. Clear for all of you, right? This is the story about return type of overriding. Okay, well. Sir, the part of overriding rules, in the last video we covered 2 points. So method names must be same, arguments must be same, which is nothing but method signatures must be matched. Next, what about return types? Sir, until 1.4 version return types must be same, but from 1.5 version onwards, covariant return types are allowed. Up to that clear. Sir, now what is the next thing? What about private? What about final? Modifiers are related rules I have to discuss. Sir, here observe a bit carefully, sir. I am taking class P, sir. Class P. Now, sir, private void M1. Are you getting private void M1 like this? I am taking, sir. Sir, it is a private method. Can you please tell, is the private method, is it visible to the child classes? Can you please confirm? Is the private method, is it visible to the child classes? No, not visible, because private means within the class only. Once this private method not visible to the child classes, then where is the question of overriding? Sir, if it is visible and the child is not satisfied with implementation, then the child is allowed to override. But first parent class private method not visible to the child, then where is the chance of overriding? Are you in the position to understand it? That's why overriding concept not applicable for private methods. Sir, for the private methods, because these are not visible to the child, overriding is not applicable for private methods concept, right? Now my question is, sir, I want to take same private method in the child class. Is it valid or not? I'm trying to override. Is it valid or not? Your respond, man. Is it valid or invalid? Remember this one. If I'm trying to override like this, 100% pakka it is valid, but it is not overriding, because it is the private method of parent class, it is the private method of child class. There is no relationship between this method and this method. Both are independent. It's a personal internal methods, right? Okay, like then immediately we may ask the question, sir, if it is the case, parent P is equal to new child I am taking P dot M1, then which method will come, sir? Can you please tell which method is going to come? Parent P is equal to new child P dot M1, which method will come? If you are calling like this, compiler will give left and right, because private methods outside of the class, how you can call? Are you getting? Outside of the class, you can't call this private method, immediately comparative method we are going to get. So the rule is very clear. Remember, private methods not visible to the child classes. Hence, overriding concept is not applicable for private methods. But based on our requirement, we can define the same private method in the child class also. It is valid, but it is not overriding. Clear, right? It's clear about private modifier, right? Sir, next, There is one more dangerous modifier is there related to overriding final. Are you getting what is that modifier, sir? Final modifier, right? Sir, here I am taking class P. Parent class method I declared as final, public final void M1. Public final void M1. Okay, like sir, now class C extends P. Class C extends P I am taking. Can you please confirm? Here just I am taking final. Just I am taking final, sir. Public final void M1 curly brace open and close. Sir, if the parent class method declared as final, bas, it is the final implementation. No one is allowed to override. Are you getting? If the parent class method declared the final, overriding concept not possible for that final method. Okay? By mistake, if I am trying to perform overriding public void M1, by mistake, if I am trying to override, immediately comparative error we are going to get. M1 in C cannot override M1 in P because overridden method is final. Remember this one, overridden method is final. That's why it is not possible. So final, is it, can you please tell, overriding concept, is it applicable for final methods or not? Not possible. If you are trying to perform overriding, what will happen? Immediately comparative error by default we are going to get. Clear for all of you, right? Sir, now just observe that, sir. Here, have a look once, sir. Parent class method is the final void M1. I am taking, sir. Class C extends P, sir, public void M1 like this. So, parent class method is the final. Parent class method is the final, but child class method is not final, sir. Child class method is not final. Of course, here final method overriding not possible, sir. Observe that. What is the comparative error we are getting? M1 in C cannot override M1 in P. What is the reason for that? Overridden method is final. So if the parent class method declared as final, then overriding concept is not applicable. Sir, suppose if I can take child class method is also final. Child class method is also final. If I can take child class method is also final, can you please tell what will happen? If I take child class method is also final, what will happen? In this case, sir, still comparative error. Once it is the final, yes, whether you are taking final or non-final, immediately comparative error we are going to get, because final methods we can't override. Clear for all of you, right? Let me summarize modifier related things, sir, regarding this overriding, sir. Observe carefully. Sir, if the parent class method is a final, I want to override child class method as either non-final or final. Are you getting? Either non-final or final, immediately comparative error we are going to get, because overriding concept not applicable for final methods, because parent already declared this implementation is the final, no one is allowed to change. That's why, right? Sir, now I have one small doubt. If the parent class method is a non-final, sir, it's not final, sir. It's not final. Now I want to override as final. Is it possible or not? Yes. Non-final to final, perfectly acceptable. But next level child, you can't override. Are you getting? Up to this, okay, well, next level child, you can't override, right? Okay? Non-final to final, acceptable. But final to either non-final or final is not acceptable. Observe carefully, right? Here observe. Sir, public, final, void, public, here non-final. Parent class method is the non-final, but child class method is the final. Observe that non-final to final. Parent class method is the non-final, but child class method is final, sir. Non-final to final, is it acceptable or not? Yes, why not? Observe carefully. Here, have a look once, sir. Perfectly itself is valid, no problem at all. So non-final to final acceptable, remember, but final to non-final not acceptable. Okay, like, sir, similarly, if the parent class method is abstract. If the parent class method is abstract means not having implementation, then I want to override that in the child class. Compulsory we should override to provide implementation. So abstract to non-abstract acceptable. You are getting abstract to non-abstract acceptable, no problem at all. Sir, if the parent class method is non-abstract, sir, implementation is there. What I want to take is, sir, I want to override this method as abstract. Is it possible or not? If the parent method is abstract, happily you should override to provide implementation as non-abstract acceptable, right? But if the parent class method is non-abstract, but I want to take the method as abstract. So child class method as abstract, possible or not? 100% pakka possible. Sir, if the child class feels that I don't want parent method implementation, my next level child is the responsible to provide new implementation for this method, then non-abstract to abstract, it is always possible. Now let me show this one. Observe carefully, sir. Sir, parent class method is not abstract. Now, sir, child class method, it is taking public abstract void m1. Public abstract void m1 I'm taking, sir. Can you please consider, is it valid or not? Perfectly, because anyway, if the class contain at least one abstract method, now let me take this one as abstract, sir. Okay, well, parent class method non-abstract, but child class method is abstract. No problem, because of this abstract, okay, next level child compulsory should provide implementation for this method. So it is hiding this implementation, it is restricting this implementation should not available to the next level child classes. That's why, so non-abstract to abstract overriding is always possible. Observe carefully, sir. Here I'm taking, let me compile. Yes, perfectly valid. Then who is the responsible to provide implementation for this? Next level child, sir. Class sub C, class sub C extends, class sub C extends C. Now this person is the responsible for public void m1. Again, new implementation, right? Sir, are you getting new implementation? This person is the responsible to provide. Now observe that perfectly itself is valid, no problem at all. So terminology is very clear. So abstract to non-abstract, non-abstract to abstract. Yes, overriding is always applicable. Okay, like, sir, what about remaining modifiers? Do you know remaining modifiers are synchronized, native, strict FP, but for our OCJA exam, these things are not required, but still just aware if the parent method is synchronized. If the parent method is synchronized to non-synchronized. Synchronized to non-synchronized. Synchronized to non-synchronized. Non-synchronized to synchronized. Sir, have you observed? Synchronized to non-synchronized, non-synchronized to synchronized, perfectly valid. Because synchronized keyword won't keep any restrictions in overriding. Sir, if the parent class method is synchronized, compulsory child class method should be synchronized. No such type of rule. If you want, you can take, otherwise you can ignore, no problem, right? Same rule applicable for native methods also. Native, non-native. Sir, it is no restrictions. Either native to non-native, non-native to native, perfectly acceptable. Similarly, strict FP to non-strict FP, non-strict FP to strict FP, acceptable, right? But anyway, sir, what about these native synchronized strict FP? For our certification, not required. That's why I'm not keeping that much clear explanation. Don't worry about that. The people who are very much interested, just go through the Google. You people can able to understand clearly, right? That's all. So now, if you observe all the rules, among all these things, only one restriction. Only one restriction. What is that restriction? Can you please cross check once? Among all these things, just only one restriction. What is that restriction? What is that restriction? Only one. final method we can't override. Sir, what about abstract? What about non-final, synchronizer, native, strict FFP? All the things are perfectly acceptable, no problem at all. Only one restriction, sir, we can't override final method. If you are trying to override final method, immediately comparative method we will get. But still, in our list, one modifier is missing. Have you remembered, have you observed, right? Static modifier is missing, sir. Static modifier, okay, there's a big story is there. That part soon we will discuss in detail. Just accept the static, all the remaining things are clear, right? Sir, in the last two videos we covered overriding rules. Have you remembered, right? Method names must be same, argument types must be same, method signatures must be same. Private methods not visible to the child classes, that's why overriding concept not applicable for private methods. Final methods we can't override except the final method. For the remaining modifiers, so no restrictions. Okay, well, up to that we covered. Now the next important point, here observe, I'm taking class P, parent class. Parent class contain a method public void M1. Observe very carefully, sir. Class P, public void M1. Class C extends P. I'm taking, sir. Class C extends P. I'm taking. Now here I'm taking protected void M1. Regarding just I'm taking protected void M1 like this, right? Can you please confirm, is it valid overriding or not? Ayo, respond, can you please tell, is it valid overriding or not? Okay, remember, if I'm trying to do like this, immediately comparative method you are going to get. What is the reason? What is the reason for that? Related to these access modifiers, do you have any rule for overriding? Very important for the exam sake. That's why you people should be aware clearly, right? Sir, while overriding, we can't reduce scope of access modifier. Means, sir, public to protected means we are reducing the scope. Sir, while performing overriding, we can't reduce scope of access modifier, but if you want, you can increase the scope, no problem at all. Regarding, but we can't reduce the scope by mistake. If you are trying to reduce the scope, immediately error we are going to get. Are you getting the point, right? So we can't reduce the scope, but we can increase the scope, no problem at all. Sir, let me show up to this. Is it really comparative method or not? Observe carefully, sir. Have a look once. Sir, parent class method is the public, but child class method I'm taking as protected, sir. Protected void M1. Immediately error by default you will get. Observe that M1 in C cannot override M1 in P. Attempting to assign weaker access privileges was public. Attempting to assign weaker access privileges was a public. This is the comparative method we are going to get, sir. So because we are reducing scope of access modifier, that's why, sir. Have you remembered somewhere in our fundamentals we covered which is having more access? Public is having. Sir, public is having. Which is having least access? Private is lesser than, default is lesser than, protected is lesser than public. Somewhere we covered these points, sir. So more access is the public, next access is the protected, next one is the default, next one is the private. Are you getting? So public to protected means we are reducing scope of access modifier. That's why itself is invalid. Comparative method you are going to get, sir. Suppose I'm taking, it is also protected. It is also protected. Is it valid or not? Yes. We are not reducing the scope. Same scope I'm maintaining. That's why perfectly itself is valid. Are you getting? Suppose if it is protected and if I can take public, is it valid or not? Boss, protected restricted to public means we are increasing the scope acceptable. Rule is we can't reduce the scope, but we can increase the scope, no issue at all. Now have a look, observe carefully, sir. Here the parent class method is also protected, like this I'm taking, sir. Protected, protected, like this, right? Now observe, happily the code compiles fine, no problem at all. Regarding protected, acceptable, right? Suppose assume parent class method is protected, but child class method is the public, sir. Parent class method is the protected, but child class method is the public. Sir, we are increasing the scope. That's why 100% pakka it is accept. Have a look once. Perfectly itself is valid. There is no doubt at all. So the rule while performing overriding, the rule is, sir, we can't reduce scope of access modifier, but we can increase the scope. Next, you should aware this one, which is having more scope, which is having least scope. Like this diagram also compulsory you have to keep in your mind. Clear, right? Now observe, sir, which is having least scope, private is having least scope. Next, when compared with the private, next default, next protected, next public. You know, somewhere while covering access modifiers, I covered these points, sir. Which is having highest scope, public. Which is having least scope is the private modifier, right? Okay, well. Now the point here is, if the parent class method is public, what about child method? Can you please tell? What is the child method? Sir, while overriding, we can't reduce scope of access modifier. If you want, you can increase the scope. Decreasing is not allowed. So, if the parent is the public, compulsory child class method should be public. If the parent is the public, compulsory child method should be public. If the parent is protected, can you please tell? Either protected or more access. More access means what? Public. So child class method can be protected or public. Regarding child class method can be protected or public. Okay, like similarly, if the parent class method is the default, can you please tell what about child class method? Either default is allowed, or protected is allowed, or public is allowed. Regarding public is allowed, right? Next, if the parent class method is private, sir. Private, what about child class modifiers? Sir, parent class method is the private. What about child method modifier? Sir, no restrictions, because overriding concept for private methods not applicable. Have you remembered, right? For private method not applicable. Remember this one. We covered already in the last video clearly about this point, sir. Okay. Anyway, now observe, if the parent class method is the public, compulsory child class method should be public. If the parent class method is the protected, child class method should be either protected or public. If the parent class method is the default, child method can be either default or protected or public. No restrictions, right? Sir, private anyway not going to participate in overriding. We are not required to have any rules. So only one rule you have to aware about these modifiers. While overriding, we can't reduce the scope of access modifier, but we can increase the scope, no problem at all. Clear, right? Sir, the next point related to overriding, of course, sometimes we may use throws exception, throws IO exception. Do you have any restrictions in overriding? related to throws keyword. Compulsory you people should aware. Observe that carefully, sir. Sir, here public void M1 throws exception parent class method. Child class method public void M1 doesn't throw any exception. Sir, here also parent method doesn't throw any exception, but child class method throws exception. Like, sir, we have almost around 8 cases I wrote on the board. Okay, I will explain all these things, but to understand this related to throws keyword, first you people should have some basic idea about checked exception and unchecked exception. Please make sure, sir, if you aware checked and unchecked exception, then you can aware clearly, right? Sir, let me put some basic idea about checked exception and unchecked exception, right? Very simple, sir. Do you know, in exception handling, I will explain in detail, don't worry. But here my target is, sir, which are checked exceptions, which are unchecked exceptions, just aware that knowledge is enough to answer this type of questions for the exam. Sir, do you know, you have which class acts as root for Java exception hierarchy? Have you remembered, right? Throwable. Yesterday we covered, I mean in the last videos we covered already throwable. Throwable acts as root for Java, all Java exceptions and errors, right? Now, throwable contain 2 child classes, exception and error. 2 child classes, exception and error. Sir, under exception, there are several child classes are there. Runtime exception, IO exception, runtime exception, IO exception. Next, interrupted exception, IE, very important, sir. Throws interrupted exception in multi-threading, very common exception. Next, servlet exception, several things are there. Under runtime exception, do you know, sir, what are various child classes are there? Arithmetic exception, null pointer exception, class cast exception, Are you getting? Arithmetic exception, null pointer exception, class cast exception. These are child classes of runtime exception. Similarly, IO exception, for this file not found exception. Are you getting? File not found exception. EOF exception, exception, Okay, sir, interrupted exception, servlet exception, there are several things are there. Even under error also, VM error. Are you getting? What is the VM errors are? Virtual machine error. Under that, okay, out of memory error. Are you getting? Out of memory error like this. Stack overflow error. Out of memory error, stack overflow error, like a ... Several things are there. Sir, please make sure in this which are checked exceptions, which are unchecked exceptions. Compulsory you people should have clarity, right? The point here is, do you know what is this one? What is this? Runtime exception, arithmetic exception, null pointer exception, class cast exception. These are child classes of runtime. Next, what is this one? Error. Under error, virtual machine error, like there are several things. Among these, which are checked exceptions, which are unchecked exceptions, there is a clear division is there. What is that division is, sir, a runtime exception and its child classes. Observe very carefully, sir. Runtime exception and its child classes, error and its child classes. Are you getting? Error and its child classes. So, are unchecked, sir. These are unchecked. Like, let me repeat again. Runtime exception and its child classes, error and its child classes are unchecked. Compiler never going to check whether you are handling or not. Except these, all the remaining things by default considered as checked exceptions, right? Are you getting? Except this part, the total remaining thing is by default considered as checked exceptions, right? Sir, can you please observe? Sir, IO exception, checked exception. exception, checked exception, file not found exception, checked, interrupted exception, checked exception, servlet exception, checked exception, right? So the important point, this is the thumb rule you should aware. Runtime exception and its child classes, error and its child classes are unchecked except this, the total remaining area is the checked exceptions, right? Okay, sir, please make sure if you aware this point, then automatically nothing will be there in our overriding rule. Are you in the position to understand, right? But which are parent class, which are child classes, compulsory this division must be aware. Arithmetic, null pointer, class cast exception, these are child classes of runtime exception, unchecked, right? But IO exception and its child classes checked only. Interrupted exception checked only. Next, error part unchecked only. Clear, right? If you aware this knowledge, then you can able to answer very easily these things, right? Sir, observe. What is the rule in overriding? What rule is there, sir? Very simple rule, sir. If child class method throws any checked exception, if child class method throws any checked exception, compulsory parent class method should throw the same checked exception or its a parent. Let me repeat again. Okay, if a child class method throws any checked exception, compulsory parent class method should throw the same checked exception or its a parent. Otherwise, compiler will get left and right. Are you getting that? Okay. So just I'm repeating again. If child class method throws any checked exception, compulsory parent class method should throw the same checked exception or its a parent. Otherwise, compile time error, right? Sir, what about unchecked exception? For unchecked exception, no rule. The rule is applicable only for checked exceptions only. Unchecked exceptions you can use anywhere, any number of times, no problem at all. Clear, right? Now, if you aware this, now observe that first point, first one. If a child class method throws any checked exception, can you please tell, in this case, child method doesn't throw any checked exception, then we are not required to worry, perfectly itself is valid. Are you getting valid? Because child doesn't throw any checked exception. Second case, child class throws exception. Child method throws exception. Sir, if child class method throws any checked exception, compulsory parent method should throw the same checked exception or its parent. But here parent method does not throw. That's why this one is invalid. Compile time error by default we are going to get, sir. Please make sure you people should aware. Now have a look once. Let me show at least once. Here, observe carefully about this one. I'm taking a simple example, sir. A simple example. Here public void M1. Public void M1. Sir, M1 parent throws exception, sir. But child doesn't throw any checked exception. If the child doesn't throw any checked exception, no restrictions, happily the code is going to compile. Happily the code is going to compile fine. Java C p.java. Observe that the code what I say about this one is p.java. Regarding this is the p.java, right? That's why Java C p.java. Happily the code is going to compile, no problem at all. Suppose if the child class method throws checked exception, but the parent class method doesn't throw that checked exception. Have you observed, right? Immediately error we are going to get. M1 in C cannot override M1 in P. Overridden method does not throw exception like this, right? So if a child class method throws any checked exception, compulsory parent class method should throw the same checked exception or its parent. Sir, suppose I want to make this one as a valid. One option, better to throw parent class method also throws either same or its parent. Either same. I'm taking M1 throws exception. Are you getting? Child class method throws some checked exception. Parent class method also throws the same checked exception. No problem. Acceptable. If the parent class method throws its parent, sir. What is the parent? Parent of exception throwable. Still acceptable. Okay, no issue at all. So the rule is, if a child class method throws any checked exception, compulsory parent class method should throw either same checked exception or it's a parent. Okay, well, so this one is the invalid, right? Now the third one, can you please observe? Child class method throws IO exception, parent class method throws exception. Sir, it is a checked. IO exception is a checked. So IO exception itself is the checked means, sir, parent class method throws its parent only. No problem at all. Acceptable. Okay. Fourth one, sir, child class method throws exception. If a child class method throws any checked exception, compulsory parent class method should throw either same exception or its parent. Sorry, it is not parent, it is not same. That's why it is invalid. Are you getting? So because parent method always throw either same or higher level, but this is the sub IO exception is the child of exception. That's why it is not, it is invalid. Okay, like. Sir, now public void throws EOF exception, file not found exception. Child class method throws EOF exception, file not found exception. Have you observed? According to our diagram, EOF exception, file not found exception are child class of IO exception. So these two are child of IO only. No problem at all. So each and every checked exception thrown by child class method, compulsory thrown by parent class method or its parent. Sir, parent already IO. Yes, more superior only. That's why no problem at all. Next, have you observed, right? Sir, public void M1 throws EOF exception. EOF exception. Sir, parent IO. No problem at all. EOF exception, parent throws IO exception, no problem. But interrupted exception, child class method throws interrupted exception which is not thrown by parent class method. That's why immediately comparative error we are going to get, sir. This one itself is invalid because interrupted exception which is the checked exception thrown by only child class but not by the parent class. That's why itself is invalid, right? If you want, let me show this one. Have a look once. Parent class method throws IO exception. Parent class method throws IO exception, but child class method throws EOF exception, comma interrupted exception, like this, right? Sir, anyway, IO exception like import java dot IO dot star must be required. Import java dot IO dot star. Now observe that the problem here is EOF exception, the corresponding parent already thrown. But interrupted exception, where is the corresponding parent? That's why the problem is coming. Are you getting? Now, let me compile this code. Let me compile. Immediately error, M1 in C cannot override M1 in P. Overridden method does not throw interrupted exception. Suppose, if this interrupted exception thrown by parent, sir, if this interrupted exception is thrown by parent, then perfectly valid, no problem at all. Are you getting? Sir, or for both the common parent is interrupted, sir, exception. If the parent class method throws exception, now also it is valid. Are you getting, right? Sir, observe various possibilities, right? So that's why this one is invalid, it's very clear. Sir, what about next, the seventh one? Public void M1 throws IO exception. Public void M1 throws IO exception. Public void M1 throws EOF exception, null pointer exception. Sir, observe. EOF exception, it's parent IO exception, already parent method thrown. But what about null pointer exception? Have you remembered? Null pointer exception is the checked or unchecked? Unchecked. That's why you can take anywhere, no restrictions, right? Valid. Okay. Now, sir, this one. Child class method throws arithmetic exception, null pointer exception. Sir, both are unchecked exception. Child class method doesn't throw any checked exception. That's why perfectly this one is valid. restrictions are applicable only for checked exception but not for unchecked exception. Child class method throws any number of unchecked exceptions perfectly itself is acceptable, but only restriction applicable for checked exceptions, right? Clear for all of you, right? All these things clearly available in our material. Don't worry, just go through that so that you people can feel more comfortable. If any case, if you are feeling sir doubt, just try to execute, automatically you can get much clarity, right? But you should aware what is the rule. Can you please spell out? What is the rules are? If child class method throws any checked exception, compulsory parent class method should throw same checked exception or its parent. That is the rule what you people should aware. But what about unchecked exceptions? No restrictions. Clear, right?